Welcome to part two of Index Management Basics. And I know I covered a lot of information in part one. I'm going to continue here in part two, but trust me, this is the basics of understanding and managing indexes, and you need to have this down going into this exam and working in the real world. So in part one, we talked about how indexes work. We compared them to books, and we closed out part one talking about the challenges that non-clustered indexes present to us because every time, in this instance, we add a new product that starts with C, it means all of these have to move down a row, and that is going to change where these are pointing into our table here. And so every time we do a data modification, our index pointers have to be updated, and our modifications get slower and slower and slower as all of these multiple non-clustered indexes have to be managed. Another thing that happens is over time, as data gets modified, deleted, and inserted, the indexes themselves become disorganized in the way they're stored. This is very similar to what we know as disk fragmentation on our hard drives, on our old physical metal-based hard drives. In the index world, this disorganization is called index fragmentation. Now, one of the many responsibilities of a SQL database administrator is to manage the indexes that exist on the tables in the databases that they're responsible for. First of all, they're going to have to repair this fragmentation. Just like every once in a while, we have to go out there and run a disk defrag on those physical platters that we have. We're also going to have to check our indexes for fragmentation because as we add non-clustered indexes and our updates become less efficient, then our indexes start to become fragmented, and that adds to the inefficiency. The first thing we need to do as a database administrator on a regular basis, check our indexes for fragmentation. This can be part of an automated database maintenance plan where we just automatically rebuild and reorganize our indexes, and that cleans out the fragmentation. A little bit later on in the course, I'm going to show you how you can check an index for fragmentation, and based on the amount of fragmentation, the action that you need to take to repair that fragmentation. So that's one of the responsibilities of a SQL database administrator when it comes to indexes. The second responsibility is to go out there from time to time and identify any underutilized indexes, especially those non-clustered indexes. We've got them out there. They're slowing down our updates. They're slowing down our data modifications. And what a waste if nobody's ever really using those indexes. Now, the query optimizer that's built into SQL Server can see all the indexes on a table, and it will look to see when it's trying to return data to a query as to whether or not certain indexes can be used efficiently. And if it can't use them efficiently, it'll just ignore them. Well, even though they're ignored when we're pulling data back, they can't be ignored when we're modifying data. So if we have indexes out there that aren't being used, we need to remove those indexes or we need to modify them. Now, a lot of times the database administrator will identify these, and they're going to have to talk to the database developers or somebody who created these and say, hey, just want you to know that these are underutilized indexes. We either need to modify them to make them useful or get them out of the database. Now, this happens quite naturally sometimes as the data that's stored in our databases changes. Over time, we'll make minor changes to the structure of our databases. And so this is going to be an ongoing responsibility of a SQL Server database administrator. Check for fragmentation, repair it, and identify underutilized indexes that are just costing us efficiency for no apparent reason. Lots going on here. Now, as we move on through the course, we're going to talk about how you can deal with these issues as a database administrator.